Today we discuss about composition of functions. First definition: if f x to y and g y to z are two functions, then the composition of f and g is denoted by g composite f. We read it g composite f, and it is defined by g composite f of x is equal to g of f of x for all x belongs to capital X. It is clear that g composite f is defined only when range f subset of y that equal to domain G. Okay, so it is clear g composite f is a function from x to z, so that domain of g composite G is equal to g composite f. Sorry, domain of g composite f is equal to that set x, and range of g composite f that is equal to g of range f subset of z. So when f composition with the function g, we get a new function g composite f, which domain is the set of x and range is the subset of z. Range is the subset of z. We represent it as diagrammatically this way, that is a x set and a y set. It is a function from x to y f, and g is a function from y to z. So g composite f that is a function from x to z. So g composite f of x, we write g of f of x for all x belongs to capital X. Similarly, we can write it. We write some note 1. Similarly, the composition of a g x to y and f y to z is denoted by f composite g, and we read it f composite g, and is defined by f composite g of x is equal to f of g of x for all x belongs to capital X. For all x belongs to capital X. Number 2, the composition of functions is not commutative in general. The composition of functions is not commutative in general. Not commutative in general. So that is g composite f not equal to f composite g. G composite f not equal to f composite g. Example exercise 1b 11 Number 11 double A. Take. Given f of x equal to sin x and g of x is equal to x to the power 5. We find a f composite g and g composite f. Then f composite g of x is equal to f of g of x, that equal to f of x to the power 5, that equal to f of x sin x, f of x to the power 5 sin x to the power 5, sin x to the power 5. Okay. Similarly, g composite f of x is equal to g of f of x, g of f of x, that equal to g of f of x means sin x. So g of sin x equal to g of sin x, g of x to the power 5, g of sin x whole to the power 5 or equal to sin to the power 5x. So f composite g not equal to g composite f. Also we take another example, same question 11, bit number IV. Given f of x and g of x both are equal, given f of x is equal to g of x equal to 1 minus x cube whole to the power 1 by 3 whole to the power 1 by 3. Now we find f composite g and g composite f. F composite g of x is equal to f of g of x, that equal to f of g of x 1 minus x cube whole to the power 1 by 3, that equal to 1 minus x cube whole to the power 1 by 3 whole cube whole to the power 1 by 3. Okay. In place of x, we put 1 minus x cube to the power 1 by 3, because g of x is equal to 1 minus x cube to the power 1 by 3. So f of x 1 minus x cube to the power 1 by 3. In place of x, we put that function 1 minus x cube to the power 1 by 3. Then simplify 1 minus x cube, that equal to whole to the power 1 by 3, that equal to x to the power cube whole to the power 1 by 3, that equal to x. Similarly, we find g composite f of x is equal to g of f of x, that equal to g of f of x 1 minus x cube to the power 1 by 3. So g of 1 minus x cube to the power 1 by 3. So we write 1 minus, in place of x we put 1 minus x cube to the power 1 by 3 to the whole cube whole to the power 1 by 3. 1 minus x cube whole to the power 1 by 3 x cube to the power 1 by 3, that equal to x. Here g composite f also equal to f composite g. So f composite g equal to g composite f. Okay. Next, we discuss about equality of functions. Equality of a function. Equality of functions. Equality of functions. Equality of functions. Two functions f of x and g of x, f of x and g of x are said to be equal, that is symbolically we can write f of x equal to g of x, f of x equal to g of x. If domain means domain f, domain of f of x, if domain of f of x is equal to domain of g of x and a codomain of f of x, codomain of f of x equal to codomain of g of x. Okay, तामने जेतबे दुईटा फंक्शन when two function are equal, then their domain equal and also codomain are equal. Example, if f r to r, real number to real number, is a function defined by f of x equal to x square and g is a function up to r plus union 0 is a function defined by g of x equal to x square, g of x equal to x square. Then even though f of x is equal to g of x, but they are not equal because their codomain sets are not equal. Here in place of in the function f of x, the codomain set is the set of real number, whereas in the function g, the codomain set is only positive real number and 0. Okay, then we write even though f of x is equal to g of x for all x belongs to R. That means if we put any real number in place of x in the function f and g, we get the same number. That is, suppose f of 2, 4 in place of f of 2, if we put minus 2, we get also 4 in place of g, same f of minus 2 also 4. So f of x is equal to g of x for all x belongs to R, but they are not equal, because codomain of f set of real number, codomain of f not equal to codomain of g, codomain because codomain of fa not equal to codomain of G. Okay. We take another problem from exercise 1B. Exercise 1B number 5. The question is so that the functions f and g defined by f of x is equal to 2 log x and g of x is equal to log x square are not equal, even though log x square is equal to 2 log x. Log x square is equal to 2 log x. Answer: given f of x is equal to 2 log x, g of x equal to log x square. So domain of f of x is equal to 0 infinity. That means 0 to infinity, excluding 0, open interval 0 infinity. Domain of g of x equal to real number minus 0. That the all set of real number except 0, because at the value of 0 log x square not meaningless, not defined. As a dom f of x equal to dom g of x, dom f of x not equal to dom g of x, dom f of x not equal to dom g of x. So f of x not equal to g of x, even though log x square equal to 2 log x. Log x square is equal to 2 log x. Okay, clear? We complete our theory part of function, then we discuss our exercise tomorrow class. Okay, thank you.